mean, I think, to go and say, all these big tech companies, AI boom is coming, I'm gonna try and do it on my own, which I think was the starting point of U.com, which is really bold and challenging, but I mean, maybe that's a good place to start. Like, U.com, the initial premise was kind of, AI is coming, the old way of doing search is gonna die, let's take a stab at it. Now, you've evolved a lot since then, but talk about what were you thinking going in and how has that thinking evolved?
Yeah, so in 2020, we started U.com wanting to bring people answers rather than lists of blue links, which is kind of what Google had been getting really, really good at for 20 plus years. And so we were eventually actually the first people to bring an LLM into a search engine context, also patented that. Don't really want to spend my time on patents, but it's an interesting one. Eventually we realized that marketing, especially in consumer, is very hard. And we have the most truthful answers, we have the least hallucinations, the most citations, but people just want something free and fast and pretty, and they wanted to have it conveniently as a default on their phone. And it's going to be really, really hard to actually dethrone Google. And so instead, we moved into enterprise, where companies actually care about the accuracy of their answers. And now we're working with all kinds of companies, from Harvey and Windsurf, coding companies, AI legal tech companies, a lot of German companies like Hanse Merkur, dpa, Deutsche Presseagentur, Wort- und Bild Verlag, and many others, and actually provide their AI and their search results to them. So that AI search infrastructure actually is the most important thing for an LLM if you wanted to not hallucinate.
So the first lesson was, even if you have great tech, maybe taking on Google on its home turf when they've already paid billions to be the default search engine might not be the right approach. What else have you seen? I mean, you've been through a bunch of these tech waves. What else has surprised you along the way of how AI has evolved? Because you saw it coming, you saw where it was going. What surprises you about where we are in this moment?
I'm not that easily surprised because I think about the future all the time. I think what is interesting is how often VCs are wrong. They're like, when we started 2020 in search, they're like, there's no innovation in search anymore. It's dead. We don't want to invest in that. And then search changed massively, right? And so it is actually possible. And so a lot of people, in a weird way, I feel like especially in AI right now, we're in this weird overhyped and underhyped state at the same time.
I feel like that's so true of so many tech things. And it's also true that, to me anyway, and I'm curious if you think this, from my perspective, in these other revolutions that AI often gets compared to, the underlying technology wasn't changing that much. There was one fundamental shift, and then 5 to 10 years of implementing it and adopting it. .com, it was like, a few protocols. And it took, there was a boom, there was a bust, and 25 years later, it's kind of everything that was hyped in the beginning.
That's right.
With AI, I feel like if I talk to a company, any of the companies, the AI pioneers, but also any of the fast-moving tech providers, and I talk to them 6 months later, things have radically shifted under the hood. Do you expect that do you agree with that, and do you expect that pace of innovation to continue? And how, if at all, do humans ever catch up if the technology, the fundamental underpinnings are changing that fast?
Yeah, I think one way to make sense of the whole AI space is that it's currently in this dual state. And I call the two states the electricity and the superintelligence state. On the electricity state, we figured out the details, right? We can take it into any industry now, and if you have enough data, you have enough compute, you have the right reward functions, you can automate any particular task pretty well. And we're seeing that now proliferate into all the different industries. But then you also have that second state where we're still striving towards more and more general purpose AIs, and to some degree, depending on how you define it, AGI is already here. Large language models are fairly general. They can help you with doctor things, and they write a poem and everything in between, right? And so, but then AI is still, for the most part, not super intelligent, meaning above general humanity or human level skills. And whenever we can build a simulation or a verifier for something then the path to superintelligence in that domain is very straightforward. I'll give you some examples. Math. You can prove things, and you know this is the proof you want to accomplish. You know the axioms, and so in between, the AI can try a lot of things and then get feedback of is each step correct or not. That means math will get automated more and more. Same with like any game. Any game.
And there's a company called Harmonic. I don't know if you've played around with it. I'm not good enough at math to use it, but I'm understanding it's actually having success. The LLM is doing well on math exams because it's read every math book. Harmonic is doing well because it can actually do math really well.
That's right, you can prove it. And in games, you can prove things. So I was never that surprised that like Go, we could solve. Chess, we can solve with AI because AI can infinitely sample and play the game and hence create training data.
So let's talk about that path to AGI, because I think that's really a lot of the investment is based on this idea that we're going to get to superintelligence and that whoever gets there first is going to reap massive rewards. I don't think there's any way you could justify the kind of spending we're having today if you didn't believe there was a pot of gold at the end of this. I think a big question is, how do we get there? And one school of thought is, you know, more compute, LLMs get you there. You just need more. And another school of thought is we really need a different approach. And I'm curious sort of where you sit. And then we can talk a little bit more about the techniques that might get us there. But from a fundamental approach, do you think LLMs get us to AGI, or is there a different path?
So I think LLMs are a piece of the puzzle. We know, for instance, in the brain, there's Broca's region, which is very relevant for language understanding and generation, and it's also a sequence model to a large degree, and it's why people sometimes have Freudian slips. They're kind of missamples from your internal LLM of sorts, but it's clearly not the whole piece. And I think in terms of the scaling laws that people have discovered, which are nice. Scaling laws basically tell you if you add more things to the x-axis, like more compute, then the y-axis will go up also a little bit. What we're seeing now is kind of a logarithmic slowdown in those improvements. So yes, we could add another 100x the amount of data or simulation and simulated data and things like that, but the gains are going to be fairly small. And so I think now is actually a new time for research. And then you can think about, well, how are we going to go about that research? And I believe the single clearest path towards superintelligence is to actually build a recursive, self-improving superintelligence. AI is code, and AI can code. And if you can close that loop in a correct way, you could actually automate the scientific method, which basically helped humanity, doing the scientific method manually helped humanity from mucking around for hundreds of thousands and maybe millions of years to actually having all these inventions in the last few hundred years. And if we can automate that scientific method, I think that will be the straight shot.
So I want to stop you there because this is an incredibly important point, and I want to make sure the audience got it. How many people get what he's saying when he says recursive self-improvement? Oh, everyone gets it. This is a great, see, that's why DLD is the best. For the two people who were too shy to raise their hand, we're talking about algorithms that get better on their own, that learn along the way. Right now, you have Anthropic comes out with a great model, Google comes out with a great model, then OpenAI, and they're trading, and they're coming out with a new model, but that's because of humans and AI working on it. The model itself is not learning and getting better. Earlier this year, or at the end of last year, I wrote a What to Expect in 2026, and we really haven't talked about it a lot. It's in a lot of science fiction. We haven't seen a lot of talk. I feel like 2026 is the year we're going to actually start talking about it, maybe doing it.
We will do it.
Well, you think this is the year we're actually doing it?
I'm on it. I waited long enough. No one's doing it, so we're doing it.
So, but recursive self-improvement, models that get better on their own, this is also the moment in a lot of science fiction where they go back to and say, that's when the robots took over. They bashed the thing. I love Terminator 2.
It's a fun movie.
How do we not have that be the case? How do we have models that can improve on their own? I mean, do we have to get everything 100% right in setting the right goals and values of a system that can improve on its own? I mean, I see that as a huge, you look at it and you're like, well, of course, a model that can improve on its own, that's a huge opportunity for productivity gains, better investment returns, all these things. But the risks seem enormous too. Do we have to get it perfect?
No. Not right away. So let me maybe define, I think self-improvement like AI, AGI is a very fuzzy term, and so it's good to maybe define it. And there are actually various gradations of self-improvement. Eric Schmidt, for instance, for him, he says self-improvement already happens when you have AI researchers who use coding tools that predict some hundreds of lines of code, and then they say, oh, that code looks good, I feed that back into my model, and now it is a form, I would say a weak form of recursive self-improvement. But the full, very strong loop is that you actually do the scientific method, like in the Karl Popper sense. Like you create a hypothesis, you do your background research checks, you choose which of the many ideas you may have, you actually implement, then you implement it in code, then you train a model, you validate, you look at the experimental results, the training curves and everything, and then if it's good and better, you create a new kind and you update yourself. Right, so that is like the really strong form of recursive self-improvement. Now, even for that, and giving it open-ended goals, you would still check whether the ideas make sense. So this idea that the AI will just run away in superintelligence and then, for some reason, want to not die and have self-preservation. It's like, well, dying doesn't even make sense for an AI, guys. Like, it's so silly. Well, how does an AI die? You just you turn off the computer, turn it back on, it's back there. It doesn't die when you turn off the computer. It's like this whole sense of it has this death and it wants to now take over the world. Like there's all these weird human psyches that people project onto AI.
I want to push you a little though,
Please.
because there are ways in which, if the goal was to optimize the productivity of this room,
Yep.
and the AI set about this task, it might decide giving all the resources to 12 people is fine, and it doesn't make sense to give food to those 3 people. So I wonder, how important are values, and do we have enough shared values as humans, and is this going to come to the forefront? Because that's the other thing I predicted a couple of years ago, hasn't quite happened yet, was that we really have a huge global disagreement, battle, whatever term you want to use, over what are the values that we want these AI systems to hold. And when we enter the world of recursive self-improvement, those values seem even more important.
I love that. 2 thoughts. One, I actually published a paper on exactly this called The AI Economist, where you give the economist a goal, like improve productivity, and then it sets taxes and subsidies, and it can now simulate in this very simplified economy billions of years of taxation and come up with better ways to optimize the goal that you give it. And in our case, the goal was maximize productivity multiplied with equality. You don't want to maximize only equality, because then we can all be equally poor, and that would kind of suck, but you also don't want to have full productivity and one person owns everything. Now, you actually describe exactly what I predict is one of the most important jobs of the future. A lot of people don't know, and most of us won't know for a while, what are all the new kinds of jobs after current jobs eventually get more and more automated. And one such job that I'm very confident is that we'll get is the one of a reward engineer. These models we know are doing reward hacking. I'll give you a very concrete example. Let's say you want to improve your customer satisfaction score, your CSAT score in your service department as a company, right? And you tell an AI that cannot just give you a prompt and then gives you back an answer, but also it will take actions for you, right? And you say, make my CSAT scores go up. What it will probably do is just create 1 million bots that then call your service center and give a 5 out of 5 rating, and then boom, it improved your CSAT score. And you're like, okay. As a reward engineer, you should have thought of that, right? And so you're like, okay, it has to be with real people and real customer. Then the AI will say, great, I'll just give everyone a $1,000 gift certificate when their DoorDash order didn't arrive, and I get 5 out of 5 customer satisfaction scores. And you're like, no, not like that. And so defining rewards, both in the most mundane customer service examples, all the way to humanity, what do we want? Do we want sustainability? Do we want productivity, equality? How do we define our values? That will be one of the biggest questions in humanity. And truth is, humanity doesn't agree on those values either.
No, and I think we're seeing that play out at a very large scale right now. You say this is the year you think we'll start to see recursive self-improving models start to be developed, more investment going that way. How does that happen? Where do you think we'll see it first? Will it be domain limited? What's the pathway to those models coming into reality?
I can't share too much, but I've started a company to do it with the people who have done the most exciting research in that area in the last decade, and so we're going to build it.
Is that U.com? Is it separate?
It's a new organization, yeah. U.com is growing so well, and revenue is growing and everything, that I was allowed to do this one also.
How many people do you have doing that right now?
Can't share anything else beyond that, sorry. I already said too much.
Do you think do you think the big guys are also working on this?
Again, self-improvement, such a broad term. In some sense, they're already doing it, but we also know, because some of the top people that used to work in that general area at the top places are all now in this new organization, so we know what they've been up to. So no one's doing it that well, no one's focused on it.
So that's obviously another big leap if we get to that. At the same time, it does seem like we've made such a huge bet on not just AI. I mean, I think there's this talk about a bubble. I think a lot of times that got simplified early on is you're either betting on AI or you're betting against AI. And I don't think that's actually the only way we're in a bubble. I think another way we could be in a bubble is AI is absolutely real. It's absolutely going to deliver the kinds of things we think it is. The time horizon is wrong, and we're over-investing now. And if you look at the dot-com bubble, the craziest ideas of the dot-com bubble, pets.com, totally a thing today. We call it Chewy. In the United States anyway. All the things that were the classic flops, furniture delivery, totally a thing today. All the things, it just took longer.
That's right.
What are the chances you think that we're in a bubble in the sense that we're committing too much capital in a time frame that returns won't be doable, even with recursive self-improvement?
Yeah, I do think in some sense we're in a rising tide. And on top of that rising tide, there are a few bubbles. Like, it's clear to me, just like 20 years ago, some of the companies were started that are now the biggest, literally like trillion-dollar companies in the world, like Amazon and Google and so on. Like, that is actually the real thing. I also think that both the fearmongers and folks with concerns about AI, as well as some of the people who are ahead of their skis in terms of the optimism and like plans for GDP, 5x increases in the next few years or so on, they're also ahead of their skis. I think it will actually take a lot longer. A lot of times we'll realize that there are physical constraints. Like AI for biology, I'm a huge fan. Tons of really exciting companies I invest in, like Peril Bio, that can reduce the time to get to the next FDA stage 3 trial from 2 years to like 2 months. And skip animal trials and test them in petri dishes and organoids, save millions of animal lives, just incredible companies coming from AI in the biotech space, but everything in bio is still going to take a long time. You still got to go through human trials at some point. And so a lot of those innovations that are rooted in physical issues will take a lot longer than people think.
And that was going to be the final area I wanted to get to. The other thing I predicted is we're going to hear a lot more about world models. And LLMs are great at the theoretical, at the written, at the conceptual, but they still have no idea what's happening even in front of the screen. How important are models that understand our physical world, that have practical knowledge, and where does that fit in with your vision?
This is maybe controversial for some, but I think word models are part of the overhyped bubble piece to a large degree. I think language is actually an incredibly useful projection of the real world into intellectual space and thought space, and it's how we communicate and how we build civilizations as humanity. I do believe world models are incredibly useful for robotics. You want to deal in the physical world, then you should have a proper physical world model. If you're not
we have a clumsy robot right there.
If you're not working in robotics, then I don't think they're as necessary. I think code is a much better, useful avenue to go down.
What's one thing that we haven't talked about that you think will be big as a direction for AI this year?
I think we're going to see basically every industry start building out those little agents, and maybe there will be then a similar disruption to people having built, past machine learning systems. In some ways, what I think recursive self-improving superintelligence will do is kind of similar to what we may have seen if you talk to the IBM Watson team that just won Jeopardy. I don't know if you're familiar with this, but Jeopardy system, big deal, game show, very popular. And you said, okay, great, you won this. Great job to the geography questions team. Great job to the celebrities questions team, music. But by the way, all of that's going to be one neural network. And the 800 of you that did that manually, we're going to have a learned system that can learn from data and do it. That is what self-improvement could do to the current labs.
Well, I look forward to sitting back a year from now and seeing where we are. Everyone, thank you so much. Richard?
Thank you.
if you enjoyed this discussion.
Thank you.